Hi everyone. So today, now in this video, we are going to be covering an important topic in data science called one-way ANOVA. So, what is the full form of ANOVA? So, ANOVA basically means analysis of variance. Okay. So, analysis of variance is the full form of ANOVA. So, basically, this involves a step-by-step process to calculate and verify a particular hypothesis. So, to begin with ANOVA, let's start directly with a question because that's how it's easy to understand ANOVA. So, the question says a researcher is testing the effectiveness of three different diets on weight loss. The data for each diet is as follows. So, what data they're taking is the weight data, the kg weight loss after 1 month. Okay, this is what is the data that will be given to us. So let's write down the data, how it looks like. So it will look like this. Diet A, the values are 3, 4, 2, 5. That means after every month, the weight loss was 3 kgs in the first month, 4 kgs in the second month, 2 kgs in the third month, and 5 kgs in the last month. Similarly, we'll have the diet B and diet C. Okay, so I'm going to be explaining complete step-by-step procedure to make sure that it's very easy for all of you to understand, because ANOVA is a very complicated question and it requires a lot of patience to understand it clearly. Please don't hesitate to rewatch the video in case you're having any queries at any point of time. So according to this question, they're asking us to test ANOVA for a 5% significance level. Okay, this is the entire question, how it will come like for your exam. Okay, now let's start the solving the question step by step. So step 1 is to state the hypothesis. So you're stating a hypothesis called as null hypothesis H naught, which means mu A is equal to mu B is equal to mu C, which basically means no difference in mean of weight loss. Okay, this is the null hypothesis, and H1, there's a second hypothesis, alternate hypothesis, also called as HA, which means at least one mean is different. Okay, so this is your first step. Always remember you have to state one thing called the null hypothesis and one thing called the alternate or first hypothesis. Okay, so now let's start with the actual solving part of the question, which mostly involves using your calculator. Okay, so the second step is compute the mean and the overall mean. Compute the means and the overall mean. Okay, so let's take the data row by row. So what three rows we have? First row is dat A, second row is dat B, and third row is dat C. So let's take it row by row, or we can also call it column by column. So for A, the mean of A is equal to 3 plus 4 plus 2 plus 5 divided by 4, which is 3.5. The mean of B, which is 7, 5, 6, 8, mu B is equal to 7 plus 5 plus 6 plus 8 by 4, which will be 6.5, and then C is 2, 1, 3, 2, and mu C is 2 plus 1 plus 3 plus 2 by 4, which is 2.0. So this is how you calculate the means in step 2 of ANOVA. Okay. Now what is the total mean? The total mean is the sum of all the values divided by the total number of values. So that's also called as the grand mean. Okay, the grand mean. So what is the grand mean? The grand mean is 3 plus 4 plus 2 plus 5 plus 7 plus 5 plus 6 plus 8 plus 2 plus 1 plus 3 plus 2 whole divided by the total number of terms, which is 12. And the grand mean you will get here as 4.0. Okay, this is your entire step 2. Remember very carefully, it's very important to know how to find individual means and how to find the grand mean. Okay, now let's move on to step 3 of ANOVA, where we have to calculate a few other terms. Okay, so it's step 3 called as computing the sum of squares. Okay, computing the sum of squares. So what does computing sum of squares mean? Sum of squares, it basically means you have to calculate three values, or you can say two values, SSB and SSW. So now what is SSB and SSW? SSB means, so I'll write the each full form individually. So SSB means between group sum of squares. So where the SSB comes from, SSB. Okay, and the second one comes from SSW, which is within group sum of squares. Okay, so these two will be calculating one by one. So let's take the SSB first. So the formula for SSB is given by n into x bar a minus x bar whole square plus n into x b bar minus x bar whole square plus n into xc bar minus x bar whole square. So here x bar is the total grand mean. Okay, and xa bar, xb bar, and xc bar are these individual means. Okay, and n is the size of this, which is 4. So for everything it's 4. So your n value is 4 in all the cases. So let's substitute the values and solve it. When you substitute, you get 4 into 3.5 minus 4 square plus 4 into 6.5 minus 4 square plus 4 into 2 minus 4 square. So when we solve this, you get 4 into 0.5 square plus 4 into 1.5 square plus 4 into 2 square minus 2 square. So on solving the whole thing, you get 4 into 0.25 plus 4 into 6.25 plus 4 into 4, which will approximately give you 42 as the answer, not approximately, the exact value. So here SSB value is calculated, which is 42. Now time to calculate SSW. Now the formula for SSW, there is no particular formula, but SSW is the total sum of square deviations within each dat. So SSW is basically SSA plus SSB, that is SS deviation. So SSDA deviation A, SS deviation B plus SS deviation C. Okay. So now SS deviation A basically means the each value minus its mean square. So see, each value minus its mean square, value minus mean square, value minus mean square, value minus mean square. So for each of the following rows, you have to perform that. So SSDA, that is the deviation of A, it will be like this: 3 minus 3.5 square, 4 minus 3.5 square, plus 2 minus 3.5 square, plus 5 minus 3.5 square. Similarly, you do it for SSDB and SSDC. So, similarly, if you solve it, you will get 7 minus 6.5 square plus 5 minus 6.5 square plus 6 minus 6.5 square plus 8 minus 6.5 square. And then SSDC, you will get 2 minus 2 square plus 1 minus 2 square plus 3 minus 2 square plus 2 minus 2 square. So these are the values you will get. So when you take each of these, put it in your calculator, you will get the first one as 5.0, second one as 5.0, third one as 2.0. So your SSW will be the sum of these two values, these three values. So 5 plus 5 plus 2, which sums up to 12. Okay. So this is the procedure of finding SSB and SSW. Okay. So this is your major step in solving ANOVA. So this step is the one that's important, and this step you have to remember by heart. So what I would recommend is take the same question, first go through my procedure and then solve it on your own once without seeing the procedure. That will help you a lot to make sure you understand every part of the question properly. Okay. So now let's move on to the last three steps. Okay. This is step 3, right? So let's go to step 4. Step 4 is compute the degrees of freedom. So why are you computing degrees of freedom? You are computing degrees of freedom because in a particular data set, okay, between the particular set, okay, between a set, okay, so between one set, you want to find the degree of freedom, and within all the sets, you have to find the degree of freedom. Okay, so there are 2 degrees of freedom you will find. First one is df between and df within. So df between is k minus 1, where k is number of elements in one set. And k between that within k within is given by n minus k, where n is total number of elements. Okay, so these two you have to remember. These two are important. Okay, so now let's calculate both the values. So what will dfb be? dfb will be k minus 1, which is 4 minus 1, which is 3. And dfw will be 12 minus 3, which is 9. So these two, no, k is not number of elements. Sorry, my bad. K is number of sets. Okay, so this is 3 minus 1, that is 2. And this is 12 minus 3, that is 9. Okay, really sorry, it's my fault. K is the number of sets. So here you have 3 sets, right? You have 3 sets, A, B and C. So K is the total number of sets, which is A, B and C. 3 sets. Okay. Now after this, the steps become fairly simple. So the last steps are step 5. Okay, step 5 is basically computing the mean squares and F ratio. Don't worry, seeing the name mean squares, you might think you have to do something like SSB or SSW again, but no. Mean square is easy to calculate. There are two mean squares, MSB, which is SSB by DFB, and MSW, which is SSW by DFW. So SSB by DFB is 42 by 2, which is 21. And SSW by DFW is 12 by 9, which is 1.33. And then what is F value? This is the important part. F value is MSB by MSW, which is 21.21 by 1.33, which will come up to 15.75. So this is your mean squares and F ratio value. The final step is you have to find the critical F value, which will be given to you in the question in usual cases. Okay, so the critical value for significant percentage 5%, which is 0.05, for DF B equal to 1 and DF B equal to 2 and DFW is equal to 9. For all these three values, the F value is given to you as 4.26. See, this value usually you have to find from the Z-score table. Okay, but sometimes it won't be given in exam. So because it won't be in exam, the value will be given to you in the exam. So basically this value will be given to you. This F value will be given to you. Okay. So now the final step is compare the F value. So what is the calculated value? The calculated value which you got was 15.75, which is way greater than 4.26, which is the actual value. Correct? So now look at the conditions. There are three conditions which you have to remember. Okay, if calculated F is greater than F actual, that is what you get in the question, then hypothesis rejected. Okay, if F calc is lesser than or equal to F actual, then hypothesis accepted. So not two conditions, not three conditions, two conditions. I took equal to as another condition, that's why. Okay, so for F calc greater than F actual, the hypothesis is rejected. And for f calc lesser than or equal to f actual, the H hypothesis is accepted. Okay, so this is your total ANOVA question. So what is the conclusion? So after this, you'll write the last line, which is the conclusion. The conclusion for ANOVA is there is a significant difference between every mean weight. So whatever hypothesis you wrote in the start of the question, this hypothesis where you said there was no difference in the mean weight loss, you are rejecting this hypothesis and telling that this is true and not this. This is not true, this is true. That is what you are verifying in the end of a ANOVA question. Okay, thank you.